My name is Yes, and I'll be doing the em1 assignment video. So I will be explaining how does the computed square graph is shifted from the basic graph y equals ax squared. So for the input for both graph, it will determine how does the graph looks like. So basically, when a equals to -1, both the graph will be doing a downward opening graph. You can see here, which I'll call it a sad face. But when a equals to +1, both of the graph will be doing the upward opening graph, which I call it a happy face. So for b over 2a, it will determine how the graph shift horizontally. So when b over 2a is 2, the graph will shift horizontally by -2, as you can see here. While c minus b squared over 4, it will determine how the graph shift vertically. So when c minus b squared over 4a is equals to 1, the graph will shift vertically by 1. This will imply for a equals to -1, 2, as you can see here. When b over 2a equals to -2, the graph will shift horizontally by 2, and when c minus b squared over 4a is 9, the graph will shift vertically by 9. So the difference between an upward and downward opening graph is that downward opening graph have a maximum point, while upward opening graph have a minimum point. So for the discriminant will determine the nature of root. So when discriminant is greater than 0 means there's two real roots. Means there's two solution. When discriminant is equals to 0 means there is one real root and it means one solution. So when discriminant is less than 0 means there's no real roots and there's no solution. And we can see here for a equals to -1, the discriminant will be 36, which means there's two solution, means there are two real roots. Like you see here for the orange line graph, it intersect the first axis at x equals to -1, and the next intersection at the x-axis is when x equals to 5. As you see here, the solution for x is -1 and 5. Means there's two solutions. So when a equals to +1, the discriminant is -4. When it's -4, the orange line graph then intersect and its x-axis. Means there's no solution, as you see here. That is all for my presentation. Thank you.